Hello everyone, welcome to the very first video of Easy Maths Note, and today as the first video I'm going to explain you the first lesson of the grade 10 syllabus, which is perimeter. So starting off, perimeter is something that you start learning from a very young age, but this lesson is a bit more complex than what it usually was. So starting off with perimeter of plane figures, just in case you know your basics, because knowing your basics is something that is very important when you go ahead with your learning. So we have a rectangle, and in a rectangle there are four sides actually. One, the long side is the length and the other side is the breadth, where the two lengths are going to be equal in value and the two breadths are going to be equal in value. So since perimeter, what you consider perimeter is the total length of the boundary of the enclosed figure, you have to keep in mind that when you are calculating the perimeter, you should consider the boundary of the entire figure. So when it comes to a rectangle, there are four sides, so we have to add the lengths of the four sides, or simply we can add the length and the breadth and multiply it by 2, as how I have shown on this particular note. Then we have a square. Square means we know it has four sides which are equal in length. So it's all about adding the four sides or multiplying one given value by 4. So for example, if I say there is a square and the square's length is let's say 5 cm, so then we have to calculate the perimeter as 20 centimeters. So I hope it's clear, and we'll move on to triangles. So in a triangle, we know there are three sides. Same goes when calculating the perimeter of a triangle, where you have to add the lengths of the three sides. So for example, if it's L, M and N, we add L plus M plus N, and always remember to use the centimeter symbol. And then we have a circle. So knowing how to find the perimeter of a circle is going to be the base of this particular perimeter lesson assigned for you in grade 10. So we know that for every circle there is going to be a center, and we have a radius, we have a diameter, we have a circumference. So radius is the distance from the center of the circle to the circumference of the circle. So when the radius is given, we can say that the perimeter is equal to 2 pi r. So what is this pi? Pi is a constant which we use in maths, and most of the time we use it when it comes to the lesson circles, and it's something that you have to keep in mind all throughout this lesson. So this pi value is 22/7, or sometimes we might say it's 3.14. But when it comes for simplifications, it's always better to keep in mind that pi is equal to 22/7, because it might make your simplifications easier than using 3.14. So I hope you understood the way how you find the perimeter for the plane figures, which is a rectangle, triangle, square, and a circle. And with that, we can move on to the lesson by identifying what a sector means. But before finding out what a sector is, we have a tiny exercise to carry out. So let's go and check what it is about. Okay, so we have a tiny exercise to work on before we move on to the more complex, I would say. Not really complex, but let's just brush up on our knowledge on finding the perimeter of the plane figures before we move on to the rest of the lesson. So first we have a rectangle, as you can see, which has a length of 7.5 cm and a breadth of 3.9 centimeters. So how I'm going to calculate this is, so as you can see, only the length of one side is given and the other side is not given, but we should know that both of these sides are equal in length, and in the same way as only one side's breadth is given, we should know that it's equal to the other side as well. So how we calculate this is, as we discussed earlier, perimeter is equal 2 times 7.5 plus 3.9. So 7.5 plus 3.9 would be 11.4. So then we can say 2 into 11.4, and this is equal to 22.8 centimeters. Also, you can make this or calculate this. You can write perimeter equals 7.5 plus 7.5 plus 3.9 plus 3.9, and you would still get the same answer. So that's not a problem. Let's see our second question. Okay, we have an L shape. So when it comes to this L shape, now this looks a bit different than the previous one, because only this side and this side is given, which is 8 centimeters and 4 centimeters. None of the other sides have their lengths mentioned on the figure itself. But we should know that this is somewhat similar to a rectangle itself, because when you add this part which I'm marking right now and this part which I'm marking right now, both of those together is equal to 8 centimeters, and the same goes with the other side as well. When you add this side and this side, both of those will equal to 4 centimeters. So this is almost similar to finding the perimeter of a rectangle. So again we can say P equals 2 into 8 plus 4. So we know 8 plus 4 is 12, and multiplied by 2 would be 24 centimeters. I hope that's clear to you as well. So I'm just erasing this off. Let's see what we have next. We have a circle. So how do we find the perimeter of a circle? Okay, let me draw this circle over here. And this says the diameter is equal to 7 centimeters. Okay, so but previously I told you that how we find the perimeter of a circle is by using the formula 2 pi r. Oh, so we do not know the radius of this. How do we find the radius? That is something very important that you should know. Let me use a red color to show you this. So always remember that diameter divided by 2 would be equal to radius. So twice the radius is the diameter, or diameter divided by 2 will give you the radius value. So for this example, we can say that the radius is equal to 7 divided by 2, which is 3.5 cm. Is that clear? Yeah. So now since we know the radius, we can easily find the perimeter, but I want to show you something important over here. So this perimeter is equal to 2 pi r, and we know 2 pi is 22 over 7, radius is 3.5. But what you can do here is, without using 3.5, you can actually use 7 over 2, which will make your simplification steps more easy. So here you go. Now we can cut 7 and 7 and 2 and 2. So we get that the perimeter of the given circle is 22 centimeters. And I hope that's clear for you. And we can go ahead with our lesson. So we shall continue, and now we have to know what a sector of a circle is. So as you can see in the diagram I've given you, there is a circle where the center of the circle is marked with a black color dot in the middle, and there is an area where you can see it's shaded in red. that is called a sector of a circle, or in simpler words I would say it's a part of a circle. But for a part of a circle to be considered as a sector of a circle, there should be certain characteristics found in this sector or the part. So those are mentioned here as well. So the first one is this sector should extend from the center of the circle. So that is satisfied in this diagram, and it has to be enclosed by two radii. So there should be two radii covering this sector, and it should include a part of a circumference. So likewise, I have mentioned what a part of a circumference is, which is this part, if you could see, and the two radii are 1 and 2. So this part is considered as a sector of a circle. So this is something very important that you should know, that you cannot call a part of a circle a sector of a circle without these three conditions being fulfilled. Then when you have a sector of a circle, there should be an angle at the center. So it's obvious that when you mark two radii, an angle is formed over here. So that angle is called the angle at the center, and usually as a practice we name it as theta. So theta sign is also given on this, and depending on the size of the sector that you have drawn, the angle at the center may vary from 0 degrees to 360 degrees. So in case if you did not understand how the angle of the degree changes with the size of the sector that you draw, I can explain you further on that as well. So look at this circle over here. When you look at a full circle, we know that it is 360 degrees. Okay, so there are no sectors marked in a full circle, and that is 360 degrees. Now look at the area which is shaded in blue color. So as we can see at a glance, we can say that it is half a circle. So a half circle is also a sector of a circle. So you see two radii, which is this and this two radii, and a part of a circumference, right? So this is 180 degrees. And when it comes to a 90-degree angle, that is a quarter of a circle. So there again we have two radii and a part of a circumference enclosing this sector. Thereby this is a sector of a circle, and it is 90 degrees. Okay, so I hope you understood what a sector of a circle is and how you know or how you find out the sector of a circle. So usually we measure an angle using a protractor, but in this lesson most of the time you might get the angle value mentioned in the diagram itself, because this lesson is not about measuring angles but about finding the perimeter. So yeah, so I hope that's clear, and let's move on. Okay, so we are going to start with the section 1.1, which is finding the arc length of a sector of a circle. So what is meant by an arc? Now we learned what a sector of a circle is, which is a part of a circle enclosed by two radii and part of a circumference. So this part of a circumference which we mentioned earlier, or this part of the circle, is the arc. Okay, so this part marked in red is called the arc. Alright, so this is something important that you should know. And before we move on, like as the first part, we have to find the arc length of a half circle. So when we can look at a complete circle, we find the perimeter with the equation 2 pi r. With 2 pi r, what we measure or what we find out is the total length of this particular line, the line which is used to draw the circle. Now, if this is divided by 2 and we obtain a half circle, what happens? We need to measure the arc length, which is this part. So what is this arc length? So the arc length, I'm going to mention it as AL. It is 2 pi r is for full circle. So since this is a half circle, we can divide it by 2. So we get the answer as pi r. I hope that's clear, but there is also another method that we use in order to find okay, so in this method too, we find the arc length using the angle at the center, which we learned a few minutes back. So when we look at a half circle, we know that the angle at the center is 180 degrees, which is half of 360 degrees. Okay, so then we know that for a 360 degree circle, we use the equation 2 pi r to find the perimeter. So in the same way, in order to find the circumference or the arc length of a 180 degree circle, what we do is we multiply 2 pi r by 180 over 360. So why we do this is 2 pi r divided by 360 and multiply by 180, because for 360 degrees, if it is 2 pi r, how do we find the circumference or the arc length for 180 degree circle? So that is by multiplying 2 pi r by 180 over 360. So this is equal to half again. So let me continue this like this. So we know that this arc length is going to be 2 pi r into 180 over 360, which is, we can cut this as 1 over 2, and what remains is 2 pi r into half. Again we get the same answer as pi r. Okay, so I hope that's clear. Then we have another important part, which is finding the arc length of a 90 degree circle. So that's easy now. We already know how this works. If we consider this as a quarter of a circle, quarter of a circle is 1/4 of a circle. Then if for a full circle, it's the way how we find the perimeter is 2 pi r. Then how we calculate the arc length for a quarter of a circle is 2 pi r divided by 4, since a quarter is 1/4 of a circle. So we can cut off this 2 into what remains is pi r over 2. So that is one method. And again, the second method is by using angle at the center. So the angle at the center is 90 degrees. We already know in a quarter circle it's 90 degrees. So it would be 360 for a 360 degree circle, it's 2 pi r. So for a 90 degree circle, it would be 2 pi r multiplied by 90 over 360, and this is 1 over 4. And we can cut this 2 and this, and we get the answer as the arc length is equal to pi r over 2. I hope this is clear. For your reference, I'm going to show you the note as well. So here we have it. Okay. So also, since I wanted to make sure that we actually understood how we find the arc length of a sector of a circle, I have an exercise. Oh, before that, we have to find out a common equation. Now, we're not going to get questions only with 180 degree angled circles and 90-degree angled circles. So we should have a common equation to find the arc length. So if you have to find the arc length of a sector of a circle, we know that if the radius of a circle is r, the perimeter or the circumference is 2 pi r. And if the angle at the center is theta, as I mentioned earlier, that as a common practice we use theta to denote an angle, we can say that the arc length, so the arc length is, in my diagram, it's from here to here, the length of the part of the circumference of the sector. So we say that the arc length, so always remember we are not finding the perimeter yet, this is only the arc length which I just drew in red. We find it by multiplying 2 pi r into theta over 360. So what comes in this theta is the angle at the center. So this is going to be the angle at the center. I hope it's clear for you. So now, as I told earlier, we can check out the exercise. Oh, here we have. Now this is, if the angle at the center of a circle is 36 degrees and the radius is 14 centimeters, what is the arc length of the sector? So now we have to find the arc length. So as you can see here, I have listed down the information that I already know. So this is a good practice that if you could get used to it, because it might make your work very easy. Just jot down whatever you know. So now looking at the equation, we know the arc length is equal to 2 pi r multiplied by theta over 360. So let's think of the unknown things. Pi is 22 over 7. Radius, it's given in the question that it is 14 centimeters. And theta is also given in the question, that is 36 degrees. Therefore, we have to find the arc length. So since I have the equation on my note, I'm not going to write it again, but let's see how we're going to simplify this. So let's say I'm just going to use an L to denote arc length is equal to 2. So we know pi is 22 over 7, r is given as 14, and this is 36 over 360. Alright, so let's see how we're going to. Now this 7, 1, 14, 2. 36, 1, 360, 10. Okay, so we can also cut this, right? Or let's keep it as 10 because dividing something by 10 is easy. Then we can say L is equal to 2 into 22 is 44. 44 into 2 is 88. And below we have 10. So therefore the answer would be 8.8 cm. So the arc length of this is 8.8 cm. It's better if you could write down the steps of the how I simplified, so it will be easy for you. Alright, I hope you understood this, and let's check out what we have as our second question. Oh, here we do. Second question. If the arc length of a sector of a circle is 22 centimeters and the angle at the center is 120 degrees, what is the radius of the circle? So now we already know the equation of how we find the arc length. And that doesn't mean you will only be asked to find the arc length of a given sector. Now since we have a lot of unknown values in this equation and we know the equation, so they might ask to find different unknown values of the equation by giving you the rest. So you should know that it's not always that they ask to find the arc length. So that is why I told you it's always easy if you write down the known information in a separate box, or just simply jot it down so that you might find it easy to understand what answer exactly you should find. Okay, so I have written this down. Pi is 22/7, r is the fact that we have to find, theta is 120, and arc length is 22 centimeters. So I'm going to fill in the equation. Arc length is 22 and it is equal to 2 into 22/7. R is what we don't know, and this is 120/360. I'm going to do the calculation. So 120 to 360 is 1/3. Yeah. Then we have to isolate R. Isolate R, and we can take 22. So we have a 7 to multiply, 3 to multiply, 2 into 22. And so this 22 can be cut off by this 22. So we have 7 into 3, 21, and 21 should be divided by 2, and that is going to be 10.5. So just in case that you missed what I just did there, R is equal to 22 into 7 into 3 divided by 2 into 22. And we can cut this off, and we have 7 into 3 is 21 divided by 2. So we have 10.5 cm remaining. Not, you can't say it's remaining, but it's the answer for our question of finding the radius. Alright, let's look what our third question is. Okay, so here we have it. It says the arc length is given, radius is given. Now you have to find the angle at the center, which is theta. Let's check it out. Again, I have mentioned whatever the information that I know out of the question. So I know that the arc length is 11, 2 is there, 22/7 is there, radius is given, and I have to find theta. Yes? So what can we do over here? Let's see how we can simplify. So 18, 1, 18 into 2 is 36. So we can also cut this 10 and 1. And let's continue. So theta will be equal to 11 we already have, 7 into 10 divided by 22. Alright, so we can cut this 11 and this 2. So we have 7 into 10 is 70. 70 divided by 2 is 35 degrees is going to be the answer. I hope you understand what I hope you understood what we did there. So I did not do the same sum over and over again, but I did all the possible ways of you being questioned by hiding different unknown facts at each different question. Okay, so I hope you understood that. And remember the easy ways of equation by cutting out and all, which I have done in red, and I hope this might help you. Now we are going to focus on section 1.2, finding the perimeter of a sector of a circle. So we already learned what a sector of a circle is. It's something like this, where you have two radii and a part of a circumference. So part of a circumference is also known as the arc, and we learned how to find the arc length. And so by now you should be able to figure out that in order to find the perimeter of a given sector, we should add the arc length with the radius and the radius. Okay, so because that covers the entire boundary, right? So the perimeter is equal to arc length, radius, and radius. So that is basically it. And let's do just one example to see how it works. Okay, so the question says, if the angle at the center of a circle is 36 degrees and the radius is 14 centimeters, what is the perimeter of the sector? And I have also given the equation to find the arc length. So first let's find the arc length. Okay, so arc length 2 into 22/7 into 14 into 36/360. So I actually extracted this question from one of the previous questions I did. So I'm not going to explain much on how you do the calculation part. So however, I found the arc length is equal to 2 into 22, 44, 44 into 2, 88, 88 divided by 10, 8.8 cm. So now I know the arc length, but that is not sufficient for you to find the perimeter. So for the perimeter, you should add arc length plus radius plus radius. So arc length we know is 8.8 plus 14 and another 14. Yes, so we know that the answer is going to be 8.8 plus 14 plus 14, that is 36.8 centimeters. Okay, so starting off section 1.3, where we have to find the perimeter of figures containing sectors of circles. So we have to apply whatever we learned for the entire lesson on this section. Okay, so here I have nothing much to explain. It's important that we do a few questions under this. So look at question number 1. The figure shows a semicircle combined with a rectangle of length 10 cm and breadth 5 cm. So if I am to draw the same figure like this, so where it says perimeter, now though it has a line, now I already told you that it's only about finding the length of the boundary. So we can always ignore this line which I just erased, because that doesn't count in as a part of the perimeter. So I'm just going to draw it with a few lines, because I don't want you to think that it is a part of the perimeter, because it is clearly not. Okay, so we have a semicircle, we have a part of a rectangle. Alright, so first of all, we'll just name this. So we have 5 over here, then we have a 14 over here, we have a 5 over here. So since this is a rectangle, and as I already told you, even if it is not mentioned, now in order to find the arc length of the given semicircle, we should know the radius, but at glance you cannot find out the radius of the circle. So you have to know that if this side is 14, this length is also going to be 14. Thereby, if the diameter is 14, radius is going to be 7 cm. That is something that you have to very clearly keep in mind. So in order to find the perimeter and to explain it to you, I am going to name these few sides. Oops. Okay, so I'm going to name this as A, name this as B, name this as C, and this as, let's say, D. So D is the arc length, A and C we know, B also we know. So let's calculate. So first let's find the arc length. So to find the arc length, we use 2 into 2 pi r into theta over 360. So I hope by now you know what I am doing. So this can be cut off, this can be cut off. So here it's 7 actually to the radius, so I can cut this off, and I have D is equal to 22 cm. Okay, alright. So since we know D, now how we find the perimeter is by adding a plus b plus c plus d, because we do not count in the side of the rectangle which is covered by the semicircle, because that doesn't count as a part of the perimeter. So a we know is 5, b we know is 14, c is 5, d we calculated as 22, right? So 22, 5 plus 5 is 10, 10 plus 14 is 24, 24 plus 22 is 46. So the perimeter of this given figure is 46 centimeters. Okay, I'm just going to show you this note as well. So how do we find the radius? By dividing the diameter by 2. So length of the arc is 22 centimeters, and we get the final answer. The total perimeter is 46 centimeters. Okay, I also have another question prepared. Okay. So, alright, so question number 2 says, in this figure, the breadth of the rectangle is 6.8 centimeters and the length of it is 14.1 centimeters. The diameter of the semicircle is 7 centimeters and you are supposed to find the perimeter of the given figure. So just like in the previous diagram, we have a part of the rectangle which we can ignore when calculating the perimeter of the given figure. Therefore, I'm going to redraw this diagram. Okay, so oops, what just happened? Okay, so I'm going to redraw this diagram, and whatever I'm drawing now with red color, we're not going to include that in finding the perimeter. So now let's write down whatever the details we know. So this is, the breadth is 6.8, therefore this side is also 6.8, this side is 14.1. So we do not know how much the rest are, but in the question it says that the diameter of the semicircle is 7. So it's the diameter, which means from here to here it's 7, not the radius, it's the diameter. So if this part which I just marked is going to be 7 centimeters, you should know that we can calculate this part, length of this part, very easily by subtracting 7 from 14.1. Therefore, this is going to be 7.1 cm. Okay, so when we are going to calculate the perimeter, we are going to add this part, this, and whatever we get as the arc length, and we're not going to include the 7 centimeter which I have marked inside the the figure. So let's find out the arc length. I'm using an L. 2 into 22 over 7. Radius is 7 over 2. I told you previously that it's better if we use 7.7 over 2 than 3.5. So we have 180 over 360. So 1 and 2, 1 and 1, 1 and 1. So finally we get 22 divided by 2. Therefore we know the arc length is 11 centimeters. So I'm going to mention it over here so that we don't forget. Now I'm going to calculate the total perimeter of the figure. We have to add 6.8, 14.1, 0.8, 7.1 and 11. Okay, now since we have defined the equation, I'm going to erase the figure. So let's see, 6.8 plus 6.8. What is 6.8 plus 6.8? 12 and 13. So that is 13.6. So I included this, There should be 14.1 and 11. It's going to be 25.1. Okay, and we have another 7.1 remaining over here. So 13.6 plus 7.1 would be 20.7, and 20.7 plus 20.7 plus 25.1. that's going to be 45.8. So that's the final answer we obtain. So here I have found the length of the answer correctly and the length of the remaining parts of the sides and the final answer. So that is the end of the first lesson, which is perimeter, and I really hope that you understood each and every part that I explained to you, and I hope it was of use for you in some sort of a way, and I'm hoping to do more videos like this in the future. If you have any questions regarding this lesson or any other lesson, you are free to drop me a message, and I'm sure I'll be able to help you out. So see you soon, and do go through this video again and again and try to get the best out of it. So yes, I'll see you soon. Bye.